All right, in this example, we're going to pretend that we're in the big booming office supply industry, and we are selling permanent markers here. We are selling X permanent markers per year at P dollars per marker. We're in like the high-end luxury permanent marker market where, I don't know, maybe it'll like make you coffee or something too. The price-demand equation for these markers is given by P equals 10 minus 0.001x. Part A says, what price should the company charge for the markers to maximize revenue, and what is the maximum revenue? So here's an example. I don't have a revenue function. All I'm given is this price-demand equation. So here's an instance where we need to know some of those business formulas that we came up with. So remember, we said that revenue is really defined by two things. It's defined by how many you sell of a thing, so the quantity, times how expensive that thing is, times the price. So in other words, it's X times P. So if I want to find my revenue function, let's go over here to do that. My revenue function is equal to X times P. What is P? That's 10 minus 0.001x. So here's my revenue function. Of course, I can simplify that a little bit. This is R equals 10x minus 0.001x squared. So here's my revenue function. The other thing that I want to do here, once we find our function, and this is good because we have found our function, make sure you remember to determine what we're trying to do with this revenue function. We're either trying to minimize it or we're trying to maximize it. Here we want to maximize revenue. So I'm just going to make a note to myself that I want to maximize this function. This is what I'm trying to do. I want to maximize R equals 10x minus 0.001x squared. So, how should we go about this? I think that no matter what, we should find our critical points. That's usually a pretty good place to start. So I'm going to start with my critical points. So let's find R prime here. My derivative is 10 minus 0.002x using our power rule. And I want to find places where my derivative is equal to 0, places where my derivative is undefined, just like we've done every other time. So I'll take 10 minus 0.002x, set it equal to 0. We're going to solve for x. So let's see, I'll have negative 0.002x is equal to negative 10. So x must be, I believe, 5,000, but I want to double check. Yes, 5,000. So x equals 5,000. That's a critical point. In this case over here, R prime does not exist. In this case, if you look at R prime is a polynomial. We don't have any additional critical points. So we've found our critical point of x equals 5,000. Now, let's say I need to find my domain next, because my domain will determine how am I going to show that this is the absolute maximum. Am I working on a closed interval or am I working on an open interval? So in this problem, I'm going to come back to this in just a second. In this problem, I'm going to think about the domain of x, and I always come back to what does x represent in our problem? We are selling x permanent markers per year. So x represents the quantity. It's the amount of the thing that we're selling. So it wouldn't really make sense for me to have a negative X value. That would mean that rather than making permanent markers, I guess I'm like actively destroying them or something like that. So one part of my domain is that X can't be negative. The way I would say that is X must be greater than or equal to 0. So it's saying X can be positive, so that would be good. That means I'm selling things, or 0, in which case I just didn't sell any permanent markers. So, okay, that's part of my domain. X is greater than or equal to 0. The other part, well, if X is greater than or equal to 0, what else do I have to work with? Because right now I have actually kind of this half open, half closed interval. I'm going to look at what other variables I have to work with, and the only other variable I see is this P dollars per marker. What does P represent? P is the price that I'm selling them at. I found in my limited market research, I found that you tend to make the most money when you charge a positive amount. That's just me. Because if you charge the negative amount, that would be like you saying, okay, here is this permanent marker, and also here's $5 for my wallet. That doesn't seem like it would make a lot of people should be paying you for the marker, right? That just makes sense. And you can probably argue about whether P should be equal to 0. You could probably make the argument either way. I'm going to go ahead and say it could be greater than or equal to 0. Maybe you have a buy one, get one free deal or something like that. But this isn't in terms of X, right? I want to be able to talk about the domain of X. Here I have something in terms of P. So I'm just going to take my price demand equation and plug that in. So P is equal to 10 minus 0.001x is greater than or equal to 0. So I'm going to solve this inequality, for X. That'll give me negative 0.001x is greater than or equal to negative 10. And then dividing by negative 0.001. Remember, that's going to change the direction of our inequality. Here I should have x is less than or equal to 10,000. So what I'm saying here for my domain is that x should be greater than or equal to 0. But less than or equal to 10,000. So really what I'm saying is it should be between those two numbers. So my domain here in this case would be 0 to 10,000. Kind of running out of room here. We'll write it right here. 0 to 10,000. And this is good that I have the domain because now I've identified in particular, this is a closed interval, which means I should use the extreme value theorem. So, okay, I'm essentially just trying to now find what is the absolute maximum on this closed interval of this revenue function that I was working with up here. So, the first thing that we'll do, and this hopefully shouldn't be an issue, but you'll want to make sure that your critical number falls into this interval, because if it's outside of that interval, we don't care about it. So 5,000, that is absolutely between 0 and 10,000, so we're good to go. Since we're working on a closed interval, I'm going to take the endpoints of my interval along with the critical point that I found, plug those into my revenue function, and then just, since I'm trying to maximize, let's pick the highest y value. So, okay, here we go. My revenue function, let's look at 0 first, just so that we don't forget to come back and do the endpoints. This is 10 times 0, minus 0.001 times 0 squared. This is just 0. Well, that's not very promising. Here, I'll take 10,000 now and plug that in for x. So I'll have 10 times 10,000 minus 0.001 times 10,000. Be careful of your zeros. And here I should find once again that, well, End up with 0. That's no good. But the other point I need to check then, remember, is my critical point that I came up with, 5,000. I'm going to plug that into my revenue function as well. And I guess just hope that I have something that's bigger than 0, because having a revenue of 0 seems like bad news for my business. So I'm going to take 5,000 and plug that in. This is 10 times 5,000 minus 0.001 times 5,000 squared. And here I should end up with 50,000 minus, here if I take 5,000 squared times 0.001, I will have 25,000. Subtracting those two gives me 25,000. So I have a choice. I can have a revenue of 0. I can have a revenue of 0. Or I can have a revenue of $25,000. I think that I know which one I would pick. I would pick the revenue of $25,000. That seems like the best for business. So, okay, let's revisit this problem, make sure that we've answered all of the questions here. First of all, it says, what price should the company charge for the markers in order to maximize revenue, and what is the maximum revenue? So I really have two questions. First, I'm going to answer this question just because I already have it. What is the maximum revenue? The maximum revenue was this highlighted number down here, 25,000. So the max revenue is equal to $25,000. The other piece of information that we were asked for here said, what price should the company charge for the markers in order to maximize revenue? So what should my price be? And for this, I'm looking at my price demand equation, P equals 10 minus 0.001x. So, okay, I'm going to take the x value that maximized my revenue. So we said x equals 5,000. That's what maximized our revenue. Our price is equal to, we said P, I already forgot our price demand equation. 10 minus 0.001x. So 10 minus 0.001x, well, that's 10 minus 0.001 times our x value, which was 5,000. So here I should have 10 minus 5 gives me I should charge $5 per permanent marker, which sounds expensive to me, but then again, what do I know? I'm not actually in the marker business. So my max revenue is $25,000. The price that I should charge for these markers is $5. So that's pretty cool. I've answered the question here. I've given them all the information that they asked for. Let's look at one more part to this problem. It says the total annual cost of manufacturing X permanent markers for the office supply company is C of X equals 5,000 plus 2X. What is the company's maximum profit? What should the company charge for each marker, and how many markers should be produced? So a few new things that we've added in here. We've added in this cost function, which that seems awfully important. And in particular, I'm going to look at the last few sentences. It says, what is the company's maximum profit? So hold on a minute there. I want to maximize the profit. So I need to come up with the profit equation. So this is going to be P, and the way I think about that profit is always revenue minus cost. So we're still working with the same problem. This is just part B to that problem that we were just looking at just moments ago. So my profit function, that's going to be equal to, well, what was my revenue function? We found that in part A. We said our revenue function, I've already lost it, right here, 10x minus 0.001x squared. So my revenue function is 10x minus 0.001x squared minus my cost function. Now be careful with this guy. I see this mistake all the time, and it drives me nuts. I'll see students do this, minus 5,000 plus 2x. They won't put parentheses around this. The reason you need to is because we're not only subtracting this 5,000, we're subtracting this 2x as well. And if you don't put parentheses around that, it's really easy to forget to distribute that minus sign. So I always distribute the minus sign through. We can simplify our profit function here. P is equal to negative 0.001x squared. 10 plus negative 2, I've got plus 8x plus negative 5,000. So here's my profit function. All right, so we have our profit function. That's good. What are we trying to do? We're trying to maximize profit. So it would really help if I had the critical numbers of this function. So I'm going to take P. I'm going to say, all right, P, let's find our derivative, P prime, which is negative 0.001x squared. And whoops, I forgot to take the derivative, didn't I? Negative 0.002x plus 8 is our derivative. I want to find where is our derivative equal to 0. So where is P prime equal to 0? Where is P prime undefined? In this case, P prime, that's negative 0.002x plus 8. We'll set this equal to 0. 8 equals negative positive 0.002x. So I should end up with x equals 4,000 here. P prime does not exist. Again, look at your P prime. We're dealing with a polynomial. Don't have any additional critical points. So x equals 4,000. This seems like an awfully important point. All right, so I found my function. I found the critical point of that function. Here I only happen to have one. I need to know the domain of this function. I need to know, well, what's the domain of my profit function here? The domain of my profit function, and actually let's do this in a different color, domain of x here. I'm going to think about a lot of the same restrictions I came up with last time. If I want to run a successful permanent marker business, first of all, x should be greater than or equal to 0. So okay, that seems to make sense. I can't make a negative number of markers. I can't have a negative quantity, so okay, x should be greater than or equal to 0. That sounds reasonable. The other value, well, if I want to maximize profit, again, if in order to have a successful business, the price that you charge should also be greater than or equal to 0. Well, hey, hold on a second. X greater than or equal to 0, P greater than or equal to 0. I swear I've seen this before. I swear I've seen this before. Oh, right, there it is. That was how we came up with the domain of x for our revenue function, the domain of R. So the domain of my profit function is actually going to be exactly the same. If your profit function depends on that same revenue function, you'll end up with the same domain. So you could, sure, go ahead and take your price equation, which our price equation hasn't changed. That's going to be 10 minus 0.001x, say that's greater than or equal to 0, and solve. But you're going to end up with x is less than or equal to 10,000 once again. So that means our domain here is 0 to 10,000. So that means we're working on, in particular, a closed interval, which tells me a lot. It tells me how I'm going to show that whatever point I come up with, I suppose, is how I'm going to find my absolute maximum. Because at the end of the day, too, I don't want to find just a local maximum. Oh, no. I don't want to find just a local. I want to find the absolute maximum. I don't want to just make a profit. I want to make the most profit that I can, because this is America. And I suppose that's what we do. So I'm going to test my endpoints and my critical point. So I'm testing these three values with my profit function. I'm going to take those points, I'm going to plug them in and see what we get back. So my profit function, let's look at 0 first. P of 0, this is equal to negative 0.001 times 0 squared plus 8 times 0 minus 5,000. This will give me a profit of negative $5,000. That's not a very successful business. That means I'm losing $5,000. Okay, well, maybe 10,000 will give me a better outcome. P of 10,000, let's plug that into our profit equation. So negative 0.001 times 10,000 plus 8 times 10,000 minus 5,000. And here I will have to, oops, I forgot to square this. I will have to crunch these numbers real quick here, so bear with me. Plus 8 times 10,000 and minus 5,000. Oh boy, guys. This is even worse. I have a profit of negative $25,000. Neither of these seem like particularly good options. Luckily, though, we found this critical point up here in x equals 4,000. All I really need is for that to not be negative, or at least be less negative. So I'm going to take 4,000, plug that into my profit function, and hopefully, fingers crossed, we'll end up with a positive value. So 4,000 squared plus 8 times 4,000 minus my fixed cost of 5,000. So here, if I take 4,000 squared times that guy plus 8 times 4,000, oops, minus 5,000. Oh goodness, thank goodness. And with a positive 11,000. So just like last time, I've got a choice. I can have a profit of negative $5,000. That means I'm losing $5,000. You can have a profit of negative $25,000, still not appealing. Or I could have a profit of $11,000. That seems a whole lot better. So here is my maximum profit, $11,000. So let's write this down before we forget to. Our maximum profit is equal to $11,000. And I can tell because I plugged that into my profit function. So what is this problem asking for? Let's make sure that we kind of give all the necessary information. What is the company's maximum profit? I just did that. What should the company charge for each marker? So what's the price? So here for this, I'm thinking about the price, and I'm still using the same price demand equation we used way back earlier in part A, that 10 minus 0.001x. So in this case, we said x was 4,000. X is always the x value that yielded that maximum. So here, it's this x equals 4,000. So 10 minus 0.001 times 4,000, which should give me, I should charge $6. And what else? Is there anything else? And it says, and how many markers should be produced? Well, that's just my x value. So the number of markers, or the quantity that I should produce, is x equal to 4,000. So here is everything my problem asked for. So I think these are a little bit nicer to work with than that first example. The first example, I will admit, I think is actually very challenging. These are a little bit more manageable just because you have either a price demand equation or a cost equation. I think that setting these problems up is a little bit easier to do. These are the types of questions that I will be asking on the exam, on your quizzes, so I would make sure that I take a look at those. And in the next video, we'll take a look at one more example involving business and economics.